Hi, in this video I'm gonna describe my project XRAG, which is basically a explainable RAG system. So what this project does, let's say you have a query and you have your LLM. You give this query to the LLM and LLM generates response for your query. But if LLM is not connected with any online resources, the answer might be a hallucinated answer, or your LLM can simply give you response that I don't know anything, because your question might be a factual question. So the LLM must be provided with the latest information so that it can generate accurate information for your query. Okay, so basically we are talking about a typical RAG system, but my project is way better than a normal RAG. When you have a query and you enter the query into our system expecting a right answer, what our pipeline does is it searches internet, it scrapes data, and it checks whether those scraped chunks, or let's say information, are actually correct for your query. After checking, the LLM will generate a response, and the LLM will also tell you from which chunk or from which page the response is coming. And this makes the response explainable, because you can actually see which fact is coming from which page so that you can verify it. So this example on your screen, you have this query and you have this response from our search engine. So all these sentences here are carefully checked through our system and they are cited by the LLM. So now you actually can see which answer is coming from which chunk. So user can enter a harmful query as well. So here we need a guardrail which can check if the query is harmful or not. If the query is totally harmful, we will reject it. If it is safe, then it will enter into our system so that we don't waste our compute. Now, as this query enters in our system, we have a small LLM which rewrites this query. Why rewriting is necessary here? Rewriting is necessary here because when user gives us a simple query, if we rewrite the query into multiple ways, then our search engine can actually find relevant documents in a much better way. So for my use case, I have used Llama 3 billion because it is small, and for this purpose, for only rewriting purpose, we can use this. This will be efficient in production. Now these multiple queries hit the internet, they get the relevant URLs and the pages. Our pipeline handles end-to-end scraping, chunking and cleaning. Now you scrape lot of chunks. I have selected 612 chunk size. So let's say we have 200 chunks. Here comes the re-retrieval and re-runner concept. So for our use case, I have used BGEM3, which is quite clever because it provides both the dense way and the sparse way to retrieve these chunks. And finally, using RRF, we combine the dense re-ranking and the sparse re-ranking. Re-ranking using a cross-encoder is a costly process. That's why we first perform the re-retrieval and then we perform re-ranker, and finally we keep only top 10 documents, or let's say chunks. These relevant chunks are given to the LLM to generate the response with citations. Now here very important question arises whether these chunks are really correct. So for this I have used another model which actually checks if the given citation is actually correct or not, and we train this also. Not only this layer is trainable, but also the LLM that we are using here, we also train it. We train it using SFT followed by DPO. So SFT teaches the format, in which format the LLM should give the answer, and to increase the faithfulness we use DPO, which basically teaches the model to prefer accurate citation over the rejected citations. Now a very good feature that I have also implemented, our pipeline is non-linear using LangGraph. So let's say our pipeline is not able to find any correct or relevant chunk back to the rewriter. So we rewrite the query again with different approach and we perform the entire pipeline again. So the question arises here, This can be costly, so we have added a limit here. So at most 3 times this can happen. So in this way, this system becomes more robust and it can find more relevant pages information for your query and ultimately give you explainable answer. Thank you so much for watching this presentation.